Hey YouTube, we're back. Day 3 of our quarantine distance learning. Hope you're still doing well. Please remember that you can always reach out to any of us. We're dedicated to helping you and making sure that this whole situation doesn't affect you terribly. We will continue with our lessons from Mr. Boothman, who will come on camera in just a second. Please make sure you're doing your work. Please, we're putting in so much time and effort into this. It would be a shame if you didn't take advantage of everything that we're doing. All right, so let's get Mr. Boothman here. Let's begin. Happy Friday, happy College Friday. You'll be able to ask me any of your college questions during today's Google Meet session. Trying to maintain a bit of normality for you. All right, let's jump right in. Now today we'll actually spend more than one day on section 7.3, so you will not have a formal exit ticket today. It will not be graded. However, I'm still going to post a Google form, okay? You'll just be asked to submit at least one question you have about today's lesson. If you don't have a question, then I encourage you to think about where someone might be confused and then submit that as a question. This will be due like usual by midnight tonight. Again, I'm not grading this, but I'll try to answer these questions during our next Google Meet session, as well as serving as your attendance for the day. Okay. All right, let's talk about section 7.3. Today we're looking at our first learning target here. I can use the dot product to find the angle between two vectors. Now, in 7.1, we looked at certain operations for vectors. We added them, we subtracted them, we multiplied them by a scalar, or divided by a scalar. But what does it mean to actually multiply two vectors together? To take one displacement and multiply it by another displacement, okay? That's a very strange idea. And to answer that question, we actually have this new concept that we call the dot product. So given two vectors, vector u equals a1, b1, and vector v equals a2, b2, then the dot product is written this way. Again, think of it as our multiplication of two vectors. Literally, it's read as u dot v. And this simply equals a1 times a2 plus b1 times b2. So if we do this, multiply our a values, multiply our b values, and add them together, notice that we are getting a number. We are getting one number. We're not getting a new vector. So this is very important. The dot product is not a vector. The dot product of two vectors is a number, it's a quantity. Again, a word for that is scalar. Okay, so dot product of two vectors is a scalar, not a vector. Very, very, very important. It's just a number, okay? Now, let's run through some examples. This concept isn't terribly difficult, but given the circumstances, I understand how it might be a little confusing. So stay with me here. Example 1. U equals the vector 3, negative 2, and v equals the vector 4, 5. Find the dot product of u and v. So we have u dot v equals, well, we take 3 times 4, a1 times a2, plus b1 times b2. And we simplify, this is 12 plus negative 10. So the dot product of these two vectors is 2. Now, if I were you, I really do like labeling these right at the start, just so I know exactly what I'm plugging in where. Again, you don't have to. Feel free to make mistakes. That's your prerogative. Okay. Let's go ahead and look at our second example here. Oh, Jaime, how nice of you to join us a little late as always. Let's look at u equals 2i plus j, v equals 5i minus 6j. written in a different way, but we still have our A1, B1, A2, B2. So the dot product is A1, which is 2, times A2, which is 5, plus B1, which is 1, times B2, which is negative 6. Make sure you're including that sign there. Simplifying, we get 10 plus negative 6, or 4. Okay. Really all there is to finding the dot product between two vectors. Okay. So I'll have some practice problems later on for you to work through, and we'll practice this a bit more on Monday before you take your formal exit ticket on this learning target on Monday. Now, what can we do with the dot product? Okay. Well, if we know the angle between two vectors, okay, there is a theorem that allows us to find the dot product without doing the calculations that we just did. Here's what I mean by that. If this is vector u and this is vector v, and we want to know what's the angle between them, okay, then we have this theorem. The dot product u dot v equals the magnitude of u times the magnitude of v times the cosine of the angle between them. All right, this right here is actually coming from the law of cosines. I'm kind of skipping over that for now because it's kind of a long explanation. It's a bit of a longer proof, but please reach out to me if you want to see that. I can point you toward where you can find that, or I'm sure you intrepid students can find that online as well. It is quite interesting. But this is known as the dot product theorem. Okay, so this formula right here is important to know. And if I'm not mistaken, this, well, we'll get there in a second. If instead we know the dot product and we want to solve for the angle between two vectors, because the dot product itself isn't terribly difficult to calculate, then we just rearrange this, solve for cosine of theta, which means dividing both sides by the magnitudes, and we end up with this pretty straightforward formula. The cosine of the angle between two vectors is the dot product divided by the magnitude of each vector. This formula right here that calculates the angle between two vectors is on your reference sheet. Okay, so that is right here on the back near the bottom, along with some other formulas for your vectors that we'll look at later. Okay, so let's look at how we can use this formula. Okay. Find the angle between vectors v and u. So vector v equals this, vector u equals this. Okay, one thing I'm noticing on your exit tickets, please be very careful. If we're talking about vectors, we must use the angled brackets. Okay, parentheses, that's a point, it's a coordinate. We're not talking about points here, we're talking about a vector, so we do have to use these specific brackets, this special notation. Now, if we want to find the angle between these two vectors, then we're using this formula. Okay, and I wrote v first just because we listed v first. Okay. We need to find each piece. So we need the dot product. A1 times A2 plus B1 times B2. So the dot product of these two vectors is 1. Okay. Now we need the magnitude of each vector. Remember, that comes from the Pythagorean theorem. So the magnitude of vector v is the square root of negative 7 squared plus 3 squared, which is the square root of 58. We could try to simplify it. We're going to end up throwing it into this formula anyway, so I would hold off on simplifying for now. And then the magnitude of vector u is the square root of -1 squared plus -2 squared, or the square root of 5. Okay. Now we plug all of this into our formula. So we have the cosine of the angle between these two vectors is 1 all over the square root of 58 times the square root of 5. And if you recall your radical rules, we can multiply these together and keep it under a single radical. And so this is 1 over the square root of 290. Okay. This is what cosine of theta equals. So as we've done so many times before, if we want to actually solve for theta, then we need to take the inverse cosine. So I'm going to continue this down here. Theta itself is the inverse cosine of 1 over the square root of 290. Okay. I recognize you probably don't have your graphing calculator with you. That's okay. You can use any calculators online. I personally really like using Wolfram Alpha. That was incredibly helpful to me in college especially. And of course, for any of your graphing needs, Desmos is a fantastic tool as well. So we plug this into a calculator. Notice it's not really specified whether we should be using radians or degrees, so whichever one you prefer is fine here. I solved this using degrees, and so I got the angle between these two vectors is 86.63 degrees. Okay. If you used radians or you were in radian mode when you did this, you're going to get an answer in radians. All right. Let's keep going. I have one more example just like this. I do want to take a second and appreciate what we just did. So we have these two vectors, the vector v, which is, again, we can put these vectors anywhere we want, -7, 3, so we're going back, and then up 3. So here's vector v, and we have vector u. And again, I can place it anywhere I want. That's what's so special about vectors. I'm just going to place it at the same starting point as I placed vector v. I'm going back 1 and then down 2. So here is vector u. And we just found the angle between these two vectors. This is a pretty powerful tool, okay? Especially once we look at applications of vectors, okay, where we use these in real-world contexts. Being able to find the angles between these displacements, very important, very helpful. Okay, so pretty interesting. Let's do this last example together, and then I'll have you do a few practice problems, and then you'll submit a question you might have from today's lesson. All right, so hopefully a little shorter than usual. We have these two vectors. Again, we want the angle between them. So we need to find each piece here. Let's start with the dot product. The dot product is 2 times 4 plus 5 times -3. That's 8 plus -15, or -7. And then we find each magnitude in turn. Magnitude of vector v is the square root of 2 squared plus 5 squared, which is the square root of 29. The magnitude of vector u is the square root of 4 squared plus -3 squared, which is the square root of 25, which is 5. Okay. So the angle between these two vectors equals -7 all over 5 times the square root of 29. Okay. Not a very pleasant number, but we're using a calculator, so we don't really need to deal with it too much. Again, I'm going to continue this down here. To get theta by itself, we will need to do the inverse cosine of both sides of this equation. So we are taking the inverse cosine of -7 over 5 times the square root of 29. Okay. Again, not terribly pleasant, but our calculator can deal with it for us. I did this in radian mode, and I got an answer of 1.31 radians. So the angle between these two vectors is 1.31 radians. Again, it didn't specify. You could have done this in degrees. That would be fine as well. You just get a different number here, and you would need to make sure to include your degree sign. That's really it for this first learning target here. So we talked about dot product, which is our way of multiplying two vectors together, and then we can use this dot product in this theorem to calculate the angle between two vectors. Again, this formula is coming from the law of cosines. Very interesting if you want to ask me more about it. I have a few practice problems for you here, and I will make sure to add in those answer keys so you know if you're practicing correctly. We'll take a formal exit ticket on this on Monday after some more practice, and I might continue, and I haven't decided yet if we're going to do 7.3b, which is a couple of more applications of the dot products, but we'll find out by our next video. Otherwise, please continue practicing with everything this unit so far. I am going through it rather quickly. That's because vectors really, at least what we're doing with them, they're not too difficult. Okay, we're not doing anything super in-depth. A lot of the tools and formulas we're using here, we've used in different contexts. Please reach out to me if you're having any issues or concerns, you have questions, join our Google Meet each day, and let me know if there's anything else I can do for you. Otherwise, please submit that exit ticket. It's just a quick ask me a question from today's lesson, and try to enjoy your weekend. All right, well, that's it for today. Please enjoy your weekend. Please let us know if you need absolutely anything, and make sure you hit that like and subscribe button.